Good morning, boys and girls. Today we are doing Lesson 15, Session 1, Explore Rate Concepts. And this is on page 347, so make sure you have a pencil and your book is open to page 347. I did want to point out the family letter that is on page 345. I don't know why my screen just froze. And it kind of explains, we've been talking about ratios. And so now we're going to talk about when we have a ratio with per pound or for every. So that way we can compare ratios by their rate. So that is helpful information. But if you turn to page 347, let's read the problem. Complete the problems about equivalent ratios. So, teams of students in Miss Sada's class make robots. The red team's robot travels 6 feet every 3 seconds. The model shows the ratio 6 to 3. Complete the model to show the equivalent ratio that tells how far the red team's robot travels in 1 second. So first of all, take a look over here. We have the red team and the blue team. So the red team goes 6 feet every 3 seconds, and the blue team goes 12 feet every 4 seconds. So how can I compare these two? Well, I am going to turn them both into 1 second and see how far they both travel. So the first question asks us, how far does the red team travel in 1 second? Notice that we have time and distance. Those are our two things that we're comparing. Here's my ratio of 6 to 3. And I want to know in 1 second, how far did my robot travel? Stop, write down your answer, and then come back and see if you got the same thing I did. And it should have been 2, because what did I do? I broke this into 3 parts. So 6 divided by 3, divide by 3, gives me 2. So my new ratio is a rate of 2 to 1, 2 feet per second. So let's continue. Number 2, a ratio that compares the number of units of one quantity to one unit of another is the quantity as a rate. You can use the word per, which means for each or for every, to write a rate. A speed in feet per second is a rate that compares distance to time. Feet per second. So per second means 1 second. Just like we travel 60 miles per hour. So that's 60 miles in 1 hour. That's our rate. So the red team's robot travels at a rate of how many feet per second? We look up here, 1 second, and they traveled 2 feet. So 2 feet per second. And that's for our red team. Now B, the blue team's robot travels 12 feet every 4 seconds. Complete the model to show this robot's rate in feet per second. Remember the time, the seconds is on our double number line on the bottom, and distance is on the top. Stop and see if you can figure out how many feet this blue team's robot travels in 1 second. So you should have figured out this is 1, 2, 3, 4. So this would be 3, 6, 9, 12. So how many feet does this one travel? 3 feet per second. And hopefully you got that same answer. So we're finding equivalent ratios, but one of my units has to be 1. So now let's go ahead and turn to the next. Oh, let's finish this. So the blue team's robot travels at a rate of how many feet per second? 3 feet per second. Let's look at the next page. This poor yellow guy, the yellow team's robot is not working properly. It travels only 4 feet every 12 seconds. Complete the model to show the robot's rate in feet per second. So be careful as you look at the double number line. Where is my 1 second mark? And I want to see if you can figure out how far does my yellow team's robot travel in 1 second. Okay, and hopefully you have figured out that this is 3, 6, 9. So here's my original 4 to 12. And now I have in 1 foot takes them 3 seconds. So to go 1 second, I should have 1/3 of a foot. I had to break that foot into 3 parts to get my 1 second. So that one's a little trickier. You had to think about where is my 1 in relationship to the others. Does your model show the yellow team's robot travels more than 1 foot or less than 1 foot in 1 second? And explain. Write down your answer and then come back and check. So you should have said the 1 second line lines up with 1 foot, which is less than 1/3 foot, which is less than a foot. So it is 1. So it's going to obviously be less than 1 foot. 1/3 foot is less than 1 foot. And let's continue here. Use your model to complete the sentences. In 1 second, the yellow team's robot travels how much of a foot? 1/3. 1/3 of a foot. And the robot travels at a rate of 1/3 per second, meaning for every 1 second, it goes 1/3 of a foot. So now that we've got them all comparing at 1 second, I can compare to see how far they have traveled. So part D, the red team, the blue team, and the yellow team race the robots. Which robot will win? And justify your answer. So why don't you write your answer down? And you should have said that the blue team is the winner. And why? Because the rate shows that the blue team travels more feet each second, so it goes faster. So the blue wins, and it's more feet per second. When I compared them all with 1 second, the blue team had more feet. So part 4, how is writing a rate related to what you know about writing equivalent ratios? Well, to write a rate, you start with the ratio, and then you write an equivalent ratio using 1 unit as one of the quantities, and you can use per to describe the number. I don't know why my computer's doing this. Okay, think about what you know, equivalent ratios. Think about when we use the counters. What are equivalent ratios? Why don't you stop, fill in this page, these 4 parts, and then come back and check what I wrote. So what is an equivalent ratio? It's a ratio that has different quantities, but it means the same comparison. So ratio has different quantities. It's hard for me to write on this. Different. Why is that doing that? Okay, it's not working for me. So you can write different quantities that make the same comparison. Let me see if I turn this off. Nope, still not working. What do you know about it? Oh, now it works. Sorry, guys. What do you know about it? You can multiply or divide. Again, it's not working. Multiply or divide both of the quantities by the same non-zero number. I have no idea why it's doing this, but we'll keep going. Examples. Let's see if it works. It works. Yay. An example, one of the things we did was we used a table. Say I had blue and I had red, and I compared them. Maybe I had a 2-to-3 ratio and a 4-to-6 ratio. So that would be one example. And then another example is when we use a double number line. And these double number lines are going to be very helpful as we do our unit rates or our rates. So these would be zeros, and then we'd have a ratio of, let's say, 5 to 1. This would be my ratio. Or equivalent would be a 10 to 2. I multiplied them both by the same number. Okay, so let's continue. Let's think about this one. The ratio of minutes to gallons of water. Pay attention to the order. We have minutes to gallons. That flows through a garden hose is 2 to 12. So 2 represents my minutes, 12 is my gallons. Carlotta says that the equivalent ratio of minutes to gallons is 6 to 1. Is she correct? What do you think? Write down your answer. And she is not correct. No, she is not correct because the ratio is a 2 to 12. If I simplified or reduced both of these and I wanted a rate, it would be a 1 to 6. She mixed up the order, so that she was not correct. If you turn to the next page, and actually, guess what? You guys are going to do this page on your own. Be sure to check the Google Classroom as to the rest of your assignment for today. But I do need you to finish this page, which is page 350. And we'll hopefully get everything done. Thanks, guys.